Hello and welcome back to Advent of Code 2018. Problem 16, day 16. Hello DJ. How goes Vietnam? Yeah, Vietnam's good. Well, my visa is almost up, so I might head to Thailand next. We'll see. Um, Music turns on. Oh, forgot to open the IDE. Okay, I think I'm ready to go. Day 16. We're like in the final 2/5 of the problems, I guess. Chronal classification. Oh yeah. Assembly code problem. Fun. Well, I don't think we had any assembly code problems this year yet. I think in 2017 there were loads of them. There were quite a few, maybe 3 or 4. Alright, as you can see, the elves defend their hot chocolate successfully. You go back to falling through time. This is going to become a problem. If you're ever going to return to your own time, you need to understand how this device on your wrist works. You have a little while before you reach your next destination, and with a bit of trial and error, you manage to pull up a programming manual on the device's tiny screen. According to the manual, the device has 4 registers, and that can be manipulated by instructions containing one of 16 opcodes. The registers start with the value 0. Every instruction consists of 4 values. Opcode, input A, B, and an output. Alright, this is a more standardized format. This is good. The opcode specifies the behavior of the instruction and how the input's interpreted. The output, C, is always treated as a register. Okay, so we don't need to handle both cases, whether it's a register or a raw value. Oh, it looks like we might have to. If something says value A, it means to take the number as A literally. Hello, Catalyzer226. Are you related to hextree.io? No, I don't know what that is. What is this? Huh. Looks fancy. No, this is nothing to do with me. Cybersecurity resources, I guess. Some company stealing my name. Ha! Never trademarked my name. Okay, well. Maybe people will show up in my stream wanting to learn cybersecurity. Okay, so okay, so we've got value A. That means we interpret the value, and if it's register A, that means we interpret basically the dictionary entry for A. Okay. But the storing is always in a register. Okay. And the instruction add I 073 is encountered. It would add 7 to the value. Wait, what? I see. Okay. Oh man, that's a lot of opcodes. What is this? Okay. It's unusual input. Okay, so it looks like... Okay, so it's not... We have separate opcodes for handling registers and values. It's not in the input for... We don't just have add, and then in the input it could be either the value or the register, which is what they did in previous problems. Here we've got separate opcodes for everything. It's a bit more work, but then you reduce ambiguity in the input, I suppose. But okay. 7 general categories. So we've got adding, multiplying, anding, oring, set, greater than. All right. So that's straightforward enough. Equality. All right. Unfortunately, while the manual gives the name of each opcode, it doesn't seem to indicate the number. What? Okay. You can monitor the CPU to see the contents of the registers before and after instructions are executed to try to work them out. Each opcode has a number from 0 to 15, but the manual doesn't say which is which. For example, suppose you capture the following sample. Oh, I see. Okay. So basically, we're trying to work out this digit here, which opcode it's referring to. So for each opcode from 0 to 15, we can keep track of a list of possibilities for it to be. So at the start, each opcode could be anything. And so as we go through each of these one by one, we can test all the possibilities and cross out all the ones which clearly can't work. So if we think 0 could be add something, but we test out that, and we get a different result to that, we can say, okay, it's definitely not add, so we can cross that one out. So eventually we'll whittle down all the possibilities, And then when we finish this, we should end up with unique... I would expect we would end up... Oh, what is this? So this is basically... Okay, fine. Let's read on. Okay, you collect many of these samples, the first section of your puzzle input. The manual also includes a small test program. You can ignore the test program for now. Alright, so the question is... Oh, it's way easier than that, than what we were thinking. How many samples in your puzzle input behave like 3 or more opcodes? Okay. That's... much easier then. We don't need to do any kind of Sudoku out of this. Okay. Hello, Ku. I'm doing another assembly code problem. The guy behind Adventure Code really loves his assembly code puzzles. This one, it seems we just have to go through each of these input-output samples and work out how many possible instructions it could have resulted in that output. And count up how many result in 3 or more. So... So there's 2 sections, so we just need to... Well... We'll just have to read it. Do some sort of loop here. Alright, so... Just copy some code from before. We don't want to go line by line. Let's say... Alright, just say... While true. Line equals f.readLine. So we'll get this before. But if we get an empty space, an empty line, where is it? So this line here, then we move into the next phase. Right, so strip, if not line, break. But we don't need to do that in part 1. Okay. So okay, we just need to pause this. So let's say uh 1, 2, 3, 4, 5, 6, 7. So 7 characters in. Just take the rest and exec that. Hang on. Okay, just call it before. Before equals exec. Does this... Will this work? Can I just do that 7 onwards? Will that turn it into a list? Does exec actually return? I think so. So it should return that list. And then the next line is the instruction. Instruction equals int x for x in line dot split. Can just put that there. And then finally the after will be this again. But instead of 7, it'll be 1, 2, 3, 4, 5, 6. All right. And then we have to read 1 extra line. And then... All right, let's test this. So try print before inst after. Unexpected indent. It doesn't like the indent. Strip. None. Okay, fine. It doesn't like what I've done. I don't really understand what exec returns, if it returns anything. It returns an any. I mean, I could be a bit hacky and do this. I don't know, it feels weird doing this, but I guess it'll work. Let's test that. There we go. Let's check that the first line is correct. 1322, 1312. Okay, fine. We paused the input. Alright, now what? We've got to write a lot of opcodes now and write their definitions. So interesting parsing technique. Yeah, I can't think what else I would do other than that. I mean, I guess I can just take that section, split by comma space, and then turn that into a int array. That's actually probably safer, but... Okay, I think we just have to write out 16 separate opcodes now, which will take a while. Define. So given no, call this instruction. Given an opcode by name, not by number. Alright, so how does an opcode work? We've got 2 inputs and an output. Okay. Okay, fine. In 1, in 2, out. But we also need the registers. Reg 1, Reg 2, Reg 3, Reg 4. So basically this is going to run the opcode on those inputs and outputs using those registers as well. And we return the 4 registers as a tuple. We should probably make these tuples so that we can actually compare equality. We'll sort that out later. Okay, so... the registers are named A, B, C, and D. Okay. I'm just having a look at the instructions, if there's anything tricky. Don't think so. We might want to... Because they're referring to the registers by letter all the time, not number. I guess for convenience we can say reg equals and then do a reg. In fact, don't even use numbers here. Call it reg A, reg B, reg C, reg D. Reg A, B, reg B, C, reg C, D, reg D. Okay, so now we just have like 15 if, 16 if conditions. All right, let's begin. If opcode is add I, let's go through each of these one by one. Add R. So in that case, store into register C. Hang on. Oh, A, B, and C are not... No, they don't refer to them as letters. They refer to them by numbers. The A, B, and C are not registers. In this, when they're saying A, B, and C, they're referring to... They're using A and B to refer to the two inputs, and C to refer to the output. Just variables. Okay, hang on. So... Okay, fine. Let's not use letters then. Just say we input reg as an array of size 4. Okay, so if opcode equals add R. If I were to modify this reg, it's going to modify the original reg by reference, or does it make a copy of reg? I think just to be safe, we should probably make reg out equals reg. Alright, so... Okay, so add R. Stores into C the result of adding register A and register B. And A and B are the numbers that we get. Okay. So depends on the type of reg. If it's an int, it won't modify it. Yeah. Yeah, so I guess it would be bad if I were to just use reg there. Because I would change, if I were to change those numbers, then if I try to use inst somewhere else, then I'm using a different contents of a list. I mean, I guess that's why I should be using tuples here. Let's do that, actually. Before equals... Let's just do before, after equals tuple, before, tuple, after. Alright, so we get a tuple here, and we say reg out equals Assume that command still works. Alright, so... But we want a list. No, okay. List reg. That will make a list version of the tuple. We can modify this now. Okay. By the way, Ku, did you do the summer challenge for coding game? Which was, what, last week? Store C is A plus B. Okay. Reg. Out. Alright, this is gonna confuse me. I've got to think these over 3 times. So, register C means register whose index is out. Yeah. Equals reg A plus reg in 1 plus reg in... Okay, this will... It would actually make sense if I just call these A, B, and C, just so I don't get confused. So if I do this, reg C equals reg A plus reg B, that matches what they've said here, but it's also correct because these are ints and they're always going to be... Yeah, okay. And then elif opcode is add I. Then reg C equals, so it'll be register A plus value B. Okay, this is straightforward. Now I can just do all of these. Mul R, so it'll be reg C equals reg A times reg B. Mul I reg C equals reg A times B. They're all RI except for the couple. Okay, so we can maybe copy this pattern. So now we've got ban R and ban I, and that is bitwise and. So reg C equals reg A, what is it, this? And ban I reg A and B. Just look that up again. Python bitwise and it is ampersand, isn't it? Yeah. Okay. And then we've got or. So it would be bor and borai. So b or r b r I. Reg c equals, so it'd be vertical line and or I vertical line. Then we've got set R and set I. Okay, these are different. Set R. This says reg C equals reg A. And set I reg C equals A. And then we've got greater than R. So we've got GTIR, GTRI, GTRR. Okay. GTIR sets register C to 1 if A is greater than reg B. Okay. Reg C equals, and then we want a Boolean expression. Well, and convert it to an int. So it'd be true if A is strictly greater than reg B. Then we got kind of 3 of these types. So we've got GTRI. So reg C is 1 if reg A is greater than B. I don't see any faster way of processing all this. I guess you just got to. And then GTRR is reg A greater than reg B. Then we've got equality. So it's the same, but okay. So we've got, so it's going to be EQIR, EQRI, EQRR. EQ, EQ, EQ. Value A is equal to register B. So it's going to be the same. We just do that and that. All right, that is all the opcodes. Does that compile? Yeah, okay. So I guess we want to paste this up here. Okay, so before is that, after is that, and the instruction is that. Okay. I guess we want a list of all the opcodes. add I, add mul R, mul I, mul I, ban R, ban I, bori, bori, set R, set I, GTIR, GTRI, GTRR, GTIR, GTRI, GTRR, EQIR, IR, EQRI. This is quite tedious, I think. The problem would be just as the same difficulty but less tedious if they just reduced the number of these opcodes. Like, we don't need this many. Alright, so hopefully those all match. We'll get an error if it doesn't. No, we won't get an error. It will. Well, oh, hang on. Else, just I forget how to throw. No, that's not a Python keyword. What is it? No, raise. Whoops. Raise exception. All right. And then we want to. Oh, damn. All these regs should be... Alright. Let's say reg in. And reg will be the reg out. There we go. So the only thing that ever changes is C. So all of these... Why did this change? So these are the 4 registers. Oh yeah, of course, any register... No! Yeah, okay. Any register can change, because C is a pointer, not the name of the key in the register. Of course, okay. So this is fine then. So we want to return but only one element should ever change between these two, before and afters. Yeah, it looks like that's the case. Yeah, okay. Return tuple reg. Alright, so okay. So we want to count how many matches we get. For opcode in opcodes, so we want to do the instruction with this opcode I'm using... Okay, inst is not a good. Let's call it instruction. No, what do I want to call this? What's a good semantic word for this? It's fine, instruction. It's not really, we're not doing an instruction though, okay. We want to do instruction, opcode, inst 0, 1, so it'll be inst 1, inst 2, inst 3, that's A, B, and C, and then we need the tuple, so the before. So if the result of that is the same as after, matches... Oh, we could do this kind of more concisely. We can say... Okay, total equals 0. So here we say total plus equal... And then we just do the boolean, which says count. No, not count. What is it? Sum 1. No, not sum. Yeah, sum. And then we want the boolean, which says this. For opcode in opcodes is greater or equal to 3. Does that actually do what I think it's doing? Maybe it's a bit of a lengthy line, but I'm saying we take, so for each opcode, we check whether the instruction applied to that opcode will give the same result as the after. We sum that, so we basically count 1 for each time that happens, and add up all those ones. And if that sum is greater or equal to 3, we add 1 to total, otherwise 0. Was it 3 they wanted? 3 or more, yeah, okay. And then let's print total. Alright. Let's see what happens. 570? I mean, it's very easy for that just to be a typo somewhere. But it'll be easy to catch with the example 570. The site is... What's happened? Okay, we'll just give it time. I think that's right. Add I malware. Should I refresh? Okay, that's correct. Part 2. Using the samples you collected, work out the number of each opcode and execute the test program. So it's kind of like just doing a Sudoku, really. We keep track of what possible... We keep track of the assignments Okay. All right. So I think I have an idea for this because this is what I assumed would be the problem one, but I guess it's quite a bit harder than part one. Um, I think we want. Okay, so assignments equals. It's going to be. So we match each. Okay, we match each integer. Or we can make this a list. So it's going to be. So it's going to be I from 0 to 15 maps. No. We don't need. Okay, so the list is going to be set of opcodes. So we transform it to a set, mutable set, for I in range 16. Okay. So to begin with, every number could correspond to 16 different opcodes. Okay. Now, when we go through this, every time... Okay, so now this is going to have to be a for loop because we need to do stuff inside. So let's say... yeah, okay. Separate this out. So for opcode in opcodes. If that matches, well, no. Yeah, okay. Okay, so we need matches equals 0. So if it matches, then we add a match. If it doesn't, then we need to take out that opcode from the possibilities up here. Okay, so we say if opcode in assignments, and then the integer will be inst 0. So if that was previously a possibility, then remove it. I wish there was a cleaner way of doing this, because if you just do remove without checking if it's actually in there, you get an error. Is there a remove? Is there a parameter or something that avoids that key error? No, I think we just have to do this every time. Remove opcode. Okay, and then total plus equal matches greater or equal to 3. Alright, so that'll give us the same answer, 570, hopefully. And then we want to just see what assignments looks like. Hopefully we get exactly one per opcode. No, we don't. So now we have to basically solve some sort of Sudoku here. We can do that by hand. Should I solve this by hand? Ah, look, because that's unique. That's a... Is there... Well, it might... It's not... Okay, there's one process you can do. You can just keep making passes through this, and whenever you see this, there's a unique possibility, then you set that and remove that from every other set. That is one way of solving it, but it may not always work, because you could have... You could have unique solutions that don't necessarily have... You can have a bunch of sets with which contract to a unique solution, but they don't necessarily have a nice, easy singleton here. That's basically how Sudokus work, isn't it? You kind of have to rule things out. And all right, let's try this programmatic approach. So while any length of the set is greater than 1 for S in assignments. So while we're not done. What do we want to do? We want to say... We want to take one of these... We want to go through each of these, and if there is a singleton, we remove that element of the singleton from every other set. Okay, it's a bit hacky. There's faster ways of doing this. Well, okay, whatever. For IS in enumerate assignments, if length S is 1, then for J in range assignments, then we go through all the others, and skip the one that's equal to our current one. So we're going through all the other J's, and we say if... So the way to fetch from a set without modifying the set is make a list of it. List S, take the 0 element, in or we could just say single equals list S0. So that is what's in that singleton. Single if single in assignments J, then remove it from that set. If it's in I, it can't be in any other J, we have to remove them all. If I do this, this might work. It could, if they were being really harsh, they would make something which isn't solvable by this approach, the greedy approach. But I think it'll be solvable. Print assignments. Single equals list S 0. List is not a generic class. What? This has not been cast to a list. This was a set. And when I applied list to it, I ended up with... Oh, whoops. Why have I used square brackets there? What did that even do? It made a list wrapped around a thing. Interesting. I didn't know you could do that. Okay, I've just never done that before. It's basically the same as doing square brackets by themselves. Alright, so list. Cast it to a list. Alright, try that. For I in range. What the? Now we've got a unique. Okay, nice. Now we have a translation table. And then, okay, so this was part one, and then we need to process all these. So we're gonna have to put all this inside the keep the file open. Oops. So this is the solution to part one, and then we just print assignments, blah blah blah. So that keeps it within the file. Okay, so now we have a unique assignment. So now, if I now do this, is the file pointer gonna take the next lines, or does it start from scratch? I always forget this. It continues where it left off. Yeah, that's what I would expect. Okay, good. So now, if not line.strip, continue, because that's an empty line. Alright, so what is the ultimate result we want? We want to know where what is in register 0. Okay. So Okay, so reg equals 0, 0, 0, 0. So for each line, instruction so inst equals as before this. Okay, so we want to take our reg and apply the instruction. So reg equals, so we want to do instruction. Now the opcode will be assignments inst 0, but then we need to do list, convert that to a list. It's just going to have a singleton. I mean, we could have cleaned up the assignments, just make it a mapping, but it doesn't matter. 0. So that is the opcode. And then we just use inst 1, inst 2, inst 3. And then the reg will be our current reg. And then we replace reg with this updated reg. And then after all of that, we close the file, print reg 0. They just want to know what's in reg 0. Also, I kind of want to see what the whole reg looks like. All right. List index out of range. Assignments inst 0. Oh, whoops. I shouldn't have copied that code without... Okay. Okay, do that. There we go. So so this is what it looks like. 503, 50320. Yeah, why not? If we're doing about 570, then maybe they're roughly adding 1 or 2 every time or something, I don't know. Correct. Okay, that was a nice problem. A bit tedious. I think they could have cut half of those instructions out and it would have been just as hard. I mean, they're not much different, are they? It's just like add and multiply and or, so like you get the point after you've done half of them. That was problem 16. So it was considered a bit easier than yesterday's problem. That's, yeah, 15 was this Dwarf Fortress, mini Dwarf Fortress game that we programmed, which was quite fun. But I had numerous bugs, which is what happens when you try to program a mini Dwarf Fortress. 16 was easier. Okay, 17 was considered harder, so in that case, I'll just have to leave it for tomorrow then, because I've got like 45 minutes before I want to go to the gym. Ugh, I never leave myself enough time. And it may take me more than 45 minutes to do the problem. I could take a sneak peek. Reservoir research. two-dimensional spring of water. So we've got kind of like line segments in 2D space. There's code at the gym between reps. I've always yeah, you could do that, couldn't you? You could it'd be like chess boxing, that sport which is quite popular in London actually, and some countries, where you alternate between boxing and playing chess with your opponent. So you're you're strengthening both your mind and your body in alternating like 5-minute rounds. What we've got here, we've got like 2D segments, and we are... Ooh, this is interesting. It looks like we have a 2D segments which can form some sort of buckets, and then you're pouring water into them and they might overflow into other buckets. Oh yeah, look. Wow, okay, yeah, this looks tough. So you got to calculate where all the water falls. And the buckets are just defined by line segments, so they could be irregularly shaped. I bet somebody has solved this with Minecraft. Or Dwarf Fortress. Actually, Dwarf Fortress might be better suited, because Dwarf Fortress simulates water more accurately. Wait, Dwarf Fortress is fully 3D, but you would need to just project it into the Z direction a bit, maybe with just 1 unit or 2 units. This looks like some sort of game might be a reasonable solution for this. Yeah, I don't expect there to be any shortcut or clever way of solving this. I think you probably just have to simulate it step by step. Like if they want, how many tiles can the water reach within? Actually, yeah, there could be some shortcuts here. But yeah, because there was a falling sand problem, which is similar to this, where sand falls, but if sand falls on another sand, then it rolls to the left or the right. Just like the sand works in Minecraft, and Dwarf Fortress, I guess, as well. Some people used those games to actually visualize it and even solve it, which is pretty cool. I think Minecraft is a bit unpredictable though, so I don't think it would accurately match it. Like sometimes sand might fall in weird ways, so it wouldn't give you a solution. Dwarf Fortress probably would. Speaking of Dwarf Fortress, I've really got to play Dwarf Fortress one of these days. It's like the ultimate thing I've been building up to after all those years of playing RimWorld. Dwarf Fortress is like RimWorld hardcore. Alright, well, I'm looking at this too much. That's just a sneak peek. That's maybe tomorrow. So... the site is running a bit slow today. Okay, so... and then after that, 18 is easier, so I might be able to do those 2 problems tomorrow. The Steam release makes it very understandable. Also, you can support the devs. Yeah, I want to get the Steam release. And, yeah, I have played the ASCII version a few times back in the day. I think if I really want to get into it, I need graphics eventually. Like, I'm not one of those people that can just play the ASCII forever. Memorize what all the letters mean. I remember stuff, like I remember capital E means elephant. Now that I have a new laptop, I think my CPU will be able to handle it too. My old laptop the CPU was kind of failing. But I managed to sell that. Wait, where's my... So... yeah, after this, only 2 years left. If I... October, November, December... I'll have to do 1 year in October, 1 year in November. And try and do more problems per day. I want to get those done. Dwarfs will make every CPU beg for mercy at like 80 plus dwarves. So, like, I always like to set a win condition when I play games, like in RimWorld. I'm not one of those people who likes playing sandboxy games just for the sake of the sandbox. As I understand it, Dwarf Fortress has what some people think of as a win condition, which is to reach mountain home status. Which is like a recognition that you've kind of attained civilization, which ticks off lots of boxes. What is the exact definition of mountain home? Hang on. Here. When the king arrives. Or queen. Promote fortress to mountain home. So you would need population 140 to reach metropolis, and then you have to attract the king. 140, okay, that's way higher than 80, so... maybe I can rent an Amazon server to play the game off. Just run an EC2 instance running Dwarf Fortress. See how far I can recklessly dig and not piss off hell, death spiral. So I just gotta make sure I don't keep cats. Cats will slow down the game a lot. Does the king have lots of special requirements as well? Need certain architectural value, offerings. Oh man, this looks like a lot of work to get to mountain home. I don't think I'll get there. Well, okay, I digress. All this talk of Dwarf Fortress is going to end up in the YouTube video. Oops, okay. Well, I'll stop there. Fun fact, a stream I watched had the deposed king of the dwarves show up to his tavern as a bard who hung around for like 10 years. Wait, so you mean... So he played a new game and a king from a previous game showed up to his new game's civilization? Or you're referring to a... I don't know much about the king, so how would he show up to a tavern as a bard? Or is that like he's no longer a king? Did he get voted out? Did they have an election process? The dwarf civ had some sort of civil war and he got kicked out. Wow. Yeah, it really makes RimWorld look like Dwarf Fortress Light by comparison, even though I love RimWorld and it's complex in its own right. Okay. Well, thanks for watching, Ku and DIJ. Probably see you tomorrow.